ISO 26262-6, Clause 8, and how we can practically enforce model hygiene using a tool called EverCheck. Right off the bat, there is a baseline truth for our entire topic today. Here it is. Model hygiene is the implementation quality. I really want you to let that sink in for a second. We aren't just talking about making a model look pretty or organized on your screen. We're talking about the fundamental structural integrity of your software units. When you look really closely at Clause 8 of ISO 26262-6, the standard doesn't just ask you nicely to be careful. It lays out strict, non-negotiable mandates. It lists 10 distinct design principles for software units, and the vast majority of them are entirely focused on this core concept of model hygiene. We're talking about rules like having exactly one entry and exit point, absolutely no recursion whatsoever, requiring initialized variables, forbidding dynamic objects and implicit type conversions, allowing 0 unconditional jumps, and strictly limiting the use of pointers. Now, in a model-based design project, you absolutely cannot afford to wait to catch these issues. These principles have to be rigorously enforced right at the model level, directly inside your Simulink and Stateflow environments. You just can't rely on discovering these violations later downstream in the generated C code. It has to happen at the source, while the architecture is actually being built. And this brings us to a massive roadblock. A real everyday pain point for engineers on the ground, because knowing that we must enforce these principles at the model level is one thing. Actually executing that enforcement, that's another entirely. Hundreds. That's the reality of modeling guidelines. Checking hundreds of rules by hand or, waiting to do it only at code review time is painfully, agonizingly slow. But more importantly, it's inherently unreliable. And the consequence of that human unreliability is what we call the late violation cascade. Let's actually trace the causal link here. Step 1, you rely on a manual rule check. Step 2, because of the sheer volume and complexity we just talked about, you inevitably miss things, which leads to the late discovery of a violation. Step 3 is where the pain really hits. By the time that code is generated, that guideline breach has already propagated into your downstream artifacts. It's spread like wildfire. And finally, step 4, because the flaw is baked into the generated outputs, you're now facing the incredibly expensive rework of your test cases and documentation. That rework drains your resources, it absolutely kills engineering morale, and it blows up project timelines because you're forcing the team to unravel a sweater that's already been knitted. We simply can't accept that manual bottleneck if we want to build safe, efficient systems. On the manual side, we have those slow, unreliable processes practically guaranteeing that late violation cascade and massive rework. But with EverCheck, the workflow is completely automated. It enforces the rules early, and it gives you out-of-the-box compliance with MAAB and MISRA SLSF rule sets, while also seamlessly supporting any project-specific rule extensions you might want to add on top of that. Now, the absolute crux of how this works is a feature called Run and Fix. And listen, this isn't just a glorified spell checker that highlights a bunch of red lines and leaves you to do the heavy lifting. The Run and Fix feature actually solves the core problem by acting early. It automatically corrects the violations that have a known, well-defined fix, just handles it for you. Then, for anything that requires nuanced engineering judgment, it flags the remainder for you to resolve. And it does all of this while the engineer is still actively working inside the model, long before the model is ever compiled or the C code is generated. To really see this seamless automation in action, let's walk through this progression on a whiteboard. Step 1, you run the rule checks natively. Step 2, EverCheck jumps in and automatically fixes those known standard violations immediately. No manual clicking required. Step 3, it flags the remaining, more complex issues so the engineer can apply their specific expertise exactly where it's needed without wasting any time on the busy work. And step 4, you compile. But this time, you are compiling a definitively clean model. The enforcement happens exactly where the standard demands it, right at the source. So it's great to have fancy automated tools, but what is the actual tangible result for the engineering team? Well, it's all about building trustworthy software units. When you use tool enforcement to get the modeling style right from the very beginning, you fundamentally alter the trajectory of the rest of your project. By running EverCheck, you're left with a well-defined, restricted subset of Simulink and Stateflow. And because you have that incredibly clean subset, every single subsequent step is simplified. Your code generation produces highly predictable C code. Your structural coverage, it suddenly becomes completely achievable without jumping through massive hoops. And your formal inspections, they're totally streamlined because there is simply less ambiguity to argue about in the room. The model isn't just functionally correct, it is built in the exact structural style that ISO 26262 expects. So we're still on the left arm of the ISO 26262V model here, but look at how much our position has strengthened. I want to leave you with this exact thought to bookend everything we've discussed today. The standard essentially states, Clause 7 made the architecture trustworthy, Clause 8 makes the units trustworthy. The next stage starts from clean code. By leveraging automated model hygiene, your unit verification and integration don't start with a mess. They start clean.